Now in this part, we'll talk about nothing new really. It's just tying everything that we talked about and how does the heart regulate itself and how does it correct high blood pressure and versus low blood pressure and so on. And first off, I just want to introduce this heart art. There's lots of them online. This is just one of my favorites that I found on there, and there is the reference for it if you're interested in looking at more. So what are the major factors? And we're going to be playing around here with these venous pressures, venous return, stroke volume, heart rate, and cardiac output, and end diastolic volume. So at this point, if you do not remember what those are, I would highly recommend that you pause for a minute, go back and review them, and then come back. So what are the major factors that determine all of these? It is really up to the venous return, and that's why I kind of highlighted it. If you have an increase of venous return, which is the amount of blood returning to the right atrium and then down to the right ventricle, that means you are expanding the right ventricle, which means you are stretching those right ventricular muscle fibers. And remember, according to Starling's law, when you stretch the cardiac muscle fibers, that increases the force of contraction. And that is translated into an increase in the stroke volume. So how can I do that? How can I increase the venous return? Well, there are several ways to do that. You basically want to bring all of that blood that is found in the veins. How can I return it back to the heart? You can increase the sympathetic activity to the veins. That will stimulate the smooth muscle fibers to contract. Stimulating those smooth muscles is kind of like, again, pumping those veins to bring the blood back to the heart. There's also an increase in the skeletal muscle pump. So when we exercise, we are using that skeletal muscle pump to increase the venous return. An increase in blood volume. So for example, if somebody is bleeding and we need to increase their venous return, we can do so by giving them a blood transfusion. So increase in blood volume will eventually translate into an increase in venous return. And there's also the inspiration movements. So that inhalation, that again is kind of like a suction movement or a vacuum that will bring the venous blood back to the heart. These two, skeletal muscle pumping and inspiration movements, those are really important when we are exercising to increase the venous return, and which translates into increase in stroke volume. So let's take the two different scenarios. What will happen if there is hemorrhage, which is a blood loss? Because we've lost blood, we are basically decreasing the venous return. When that happens, because of the low venous return, that leads to the decrease in stroke volume. So the amount of blood returning to the heart is low. That means that the amount of blood pumped out of the heart is also going to be low. And that's why hemorrhage leads to a decrease in blood pressure. That's why hemorrhage leads to hypotension, because you've decreased the venous return to the heart, which translates into a lower stroke volume. And we can see that as hypotension. Now it's up to these baroreceptors, again, to detect these changes and to, through a reflex, to adjust and correct these changes. So where are the receptors? These are known as baroreceptors because they pick up pressure changes. We will find them in the aortic arch, and those are known as the aortic arch baroreceptors. There are other receptors found in the carotid sinus, which is exactly at the bifurcation of the common carotid into the internal and external carotid arteries. So the carotid sinus has baroreceptors. And remember, these were the exact same spots where we had chemoreceptors when we were talking about the respiratory system. So those two bodies have the aortic body and the carotid sinus have baroreceptors as well. They're going to pick up changes of blood pressure and transmit that to the central nervous system. So there's a reflex that has a center in the medulla, and we will see these components and how can it change our blood pressure? How can it try to correct the blood pressure? It is basically due to playing around with the sympathetic and the parasympathetic innervation. So again, any change in arterial pressure, that will change the firing of the arterial baroreceptors, and that will lead to changes in how much sympathetic or parasympathetic impulses are going to the different structures. So we are going to talk in this scenario here what happens in the case of hypertension. So in hypertension, that means the blood pressure is higher than normal. The baroreceptors are going to pick up that change and increase their firing to the medullary cardiovascular center, which is obviously found in the medulla oblongata. As a reflex, the motor component of this reflex, or the efferent component, would decrease the sympathetic impulses going to the heart. That decreases your heart rate, and it also decreases the force of contraction. It'll decrease the sympathetic outflow to the arterioles and veins, and that leads to the vasodilation of these blood vessels. And when you vasodilate blood vessels, that decreases blood pressure. Another thing it does would be to increase the parasympathetic impulses to the heart. And when you do that, if you guys remember, that decreases the heart rate. So eventually, with all of these changes that this reflex made, the arterial blood pressure would go back down to normal. So what is the reflex if we're in an opposite scenario where we want to compensate for hemorrhage? So in hemorrhage, there's obviously hypotension, and when we already talked about why that happens, we've basically lost a lot of blood. So there's a decrease in blood volume leading to that hypotension. Well, that change in blood pressure will be picked up by the baroreceptors. Now the baroreceptors are going to decrease the parasympathetic impulses going to the heart and increase the sympathetic impulses going to the heart. All of these changes will increase the heart rate because you stimulated the SA node. It will also increase the sympathetic impulses to the veins and arterioles, which will lead to their constriction. And remember, when you constrict arterioles, you're increasing the peripheral resistance, which increases blood pressure. And when you constrict veins, you're increasing the venous return to the heart, which eventually increases the stroke volume. All of these changes combined, increase in heart rate, increase in stroke volume, which obviously translates into an increase in cardiac output, plus the increase in peripheral resistance, all of those would increase your blood pressure back to normal. Now this ends this portion. I would recommend that you might want to listen to it more than once. The whole system is tied together. There really is no new information in here. It's pretty much tying everything that we've learned in the chapter in order to understand how the body can correct hypertension versus hypotension.